Hi guys, welcome to my YouTube channel. Today we'll be talking about outliers. We know the importance of outliers in feature engineering. So what we'll be covering in this session is first is to identify outliers. What are the different techniques of identifying outliers? Where we'll be talking about z-score method. Then we'll be talking about IQR method. Then we have percentile based method, and the fourth one is Wilsorization, right? Then when once we have identified outliers, the second thing what we will be covering is how can we treat outliers. So we'll be talking about techniques like trimming, then capping, treating like missing values, and applying all the techniques what we have learned in missing values, right? So let's deep dive into the first thing. We should understand that why do we need to remove outliers from the machine learning model. So consider a case where we are plotting marks obtained by a student with respect to the time spent by that you student for studying, right? So if we plot with marks on x-axis, sorry, y-axis, and r on x-axis, and we plot this point, right? So if we draw a linear regression line, this should pass like this, right? Now imagine there are some outliers in the data set where you see there are few students who score good marks but spend very less time, right? So for those, if we try to plot a linear regression line, it would fall something like this, right? Because these outliers will shift, will cause some deviation in the linear regression line, right? So you should understand all the ML algorithms which are weight based, where we calculate weights, would be impacted by outliers. So some of them are, one is linear regression, second is logistic regression, then third is a famous technique in ensemble algorithms is adder boost. Then we have deep learning algorithms. So all these algorithms are subjected to outliers, right? There are some weight tree-based algorithms like decision trees, right? Random forest. These are not subjected to outliers, right? So you don't need outlier treatment for these, but for all the algorithms where we have a weight-based calculations would be impacted by outliers. Now let's deep dive into how can we identify outliers. So guys, as we talked about identifying outliers, we have different methods based on the distributions, right? So if we have a normal distribution, then we can have skewed distributions, and we can have other distributions, whatever we have, right? Generally, for normal distribution, we have z-score treatment. Then for skewed distributions, we use box plots or IQR ranges to identify outliers in skewed distributions. And for any other distributions, we use the percentile based approach. Let's understand each in detail. So in z-score and normal distribution, we know a normal distribution looks like this. something like a bell curve, right? Where you have a mean, you have first standard deviation, you have two standard deviation, and you have three standard deviation. Similarly, on the other side, you have one standard, two standard, and three standard deviation. So you should know there is a 68, 95, and 97 rule which exists. What this rule says that within one standard deviation, 68.2% of the data false. Within two standard deviation, around 95% of the data false. And for three standard deviations, around 99.7% of the data is present. So if I plot, this one standard deviation would be around 68.2, right? If you plot for two standard deviations, it would be 95.4, and if you have three standard deviations, that would be 99.7. So you know that if the data, if the outlier lies beyond this three standard deviation, that is, we know that 99.7% of the data would fall under this category, right, or within three standard deviation. But if there is any point who lies here beyond three standard deviation, that will be classified as an outlier. It's an outlier, right? Let's take an example where you are given age as right. Now you need to identify what is an outlier in this data set, right? Intuitively we know that 80 is an outlier, but how can we find this, right? So for converting any normal distribution, what we have, right, this is a normal distribution, we can convert it into a standard normal distribution. Now, what is the difference between a normal distribution and standard normal distribution, right? So, normal distribution has a mean of mu and sigma, right? However, for standard normal distribution, we have mean is equal to 0 and say standard deviation is equal to 1, right? So, for a standard normal distribution, it will always be 0, this will be 1, this will be 2, similarly, this will be minus 1, this will be minus 2. So if you want to do this transition from normal distribution to standard normal distribution, you do a z-score transformation, right? So for z-score transformation, you should know that there exists a formula z is equal to xi minus mu upon standard deviation, right? So in this, for example here, where we are given a age value, let's calculate z value for each of them, right? So for the first factor where z is equal to for 1, we'll have 1 minus of mean. Mean would be something like 80 plus 4 plus 3 plus 2 plus 1 divided by standard deviation of some whatever it is, right? So we calculate z value here. So whenever the z value of that data set, let's consider it is 5, right? So the standard deviation here would be 1, right? Now what we'll do is we'll calculate z value for each of these values, and whenever the z value is beyond this 3, if z value is greater than, if mod of z value is greater than equal to 3, then you'll call it as an outlier, because we know that beyond 3 standard deviation, that is mu plus 3 sigma and mu minus 3 sigma, if it is greater or lesser than that, then it's a called as classifier. Here mu for standard normal distribution, mu is equal to 0 and sigma is equal to 1. So if mod of z value is greater than 3, then it's called as an outlier, right? So basically this is how we find an outlier, where we do the z-score transformation, and if mod of z value is greater than 3, then it's considered as a outlier. The second approach is what we call it as an IQR based approach, which is called as interquartile range. So for this, you need to understand that how a box plot looks like. A box plot has a median value. It has Q1, Q3, right? So here what we call it as IQR is Q3 minus Q1, right? We have an upper bound which is called as Q3 plus 1.5 times of IQR, and we have Q1 minus 1.5 times of IQR, right? So most of the data set lies into this, but any data set which lies beyond the maximum upper bound, right? The red ones, or below the minimum bound, those are classified as outliers. So this is the max and this is the minimum. So if any value doesn't lie between this range, it's considered as an outlier. So this is an outlier and this is an outlier. Both of them are outlier. Right? Now, the third approach what we have is a percentile based approach. So guys, this first approach we generally use it for normal distribution where we use z-score. For skewed distribution we use the box plots, and for the other distribution we use a percentile based approach. What does percentile based approach is? We just see the distribution, whatever the distribution looks like. We find out the 2.5 percentile, right, and we find out the 99.97.5 percentile, or basically we decide the threshold, whatever we want to see. We want to say 99 percentile, or 98 percentile, 97 percentile. We can decide on our business case, and we can say any value that lies above 99 percentile is an outlier for us, or below 1 percentile is an outlier for us, right? So this is an important technique which is used. So once we have identified uh, outliers exist or not using these three methods, we go with two methods for basically we have three methods of treating outliers, right? We have method of trimming. In trimming, what we do is we just drop the outliers, right? The second method what we have is capping, and the next method is treating like missing values. Guys, hope you are understanding it. If you are liking this content, please do subscribe to the channel. I'll be talking in detail about the different techniques and all in feature engineering. So this playlist is gonna be super helpful for you guys, right? So once we have discussed how we do is trimming is basically we drop the outlier records. Now this should only be taken up. This is definitely a fast approach, but this should only be taken up once if the data set is big enough. The second one is capping. So in a distribution, the outliers will always lie beyond a particular limit, right? These are the outliers. They can't lie within this region. So what we do is we cap the any value which is beyond this, we cap it to this particular value. Anything which is below this, we'll cap it to this particular value. So this is how we deal with outliers, where we cap the maximum and the minimum bound. Anything that exceeds that will have a value of maximum value and the minimum value within the distribution. The third one is where we consider outliers as a NaN value, and we do the imputations where we discussed about imputation using the classifier model or using the statistical techniques like mean, median, and mode. Guys, please do refer to a video of how to treat missing values. I've already uploaded this video in the playlist, so definitely do check it out. This will be helpful to understand this. Generally, we go with the trimming approach, and if the dataset is less, we do the capping approach. Rarely we use missing values, right? So yeah, guys, in this session what we discussed is an importance of outliers and what impact they have on machine learning models. Post that, we learned about what are the different ways of identifying a outlier, where we talked about z-score method, we talked about skew box plots, then the percentile based rank approach. Once we have identified the outliers, we go about handling them using the trimming, capping, and treating like missing values. So yeah, definitely if you like this channel, please subscribe and continue learning.